So next I'm going to hand it to Les for the photo gallery application demo.
Thanks, Eric. And in this part of our presentation, we are going to review the photo gallery sample application, which we built. And photo gallery is a event-driven application, and we built it to meet the following requirements. The user must be able to create photos in the photo gallery, and for each photo, we store the name of the photo, and we also organize the photos into categories. So we have photos of animals and buildings and photos of people. And then while the user is browsing through a photo gallery, he can find a photo which he likes, and we allow for the user to add the likes to the photos. There is a button displayed next to each photo so that user can click it and add likes. And the third requirement here is that for each category, we want to display to the user the list of most popular photos. So with these requirements, we came up with the following architecture. We are having 3 services here: a photo service, a like service, and a query service. And each of these services has a dedicated data store, and the services are communicating via the browser by sending messages. Let me walk you through a workflow where user is creating a new photo. For that, a user sends a post request to the photo service, and the photo service will store the information about the new photo into its database, as well as it publishes a message, photo created, onto the message browser. Next, when the user clicks the likes button, a request is coming to the likes service to add a like to the photo. Like service is managing the count of the likes for the photo, and it will store the new count, as well as it will publish a message about the current number of likes for the given photo onto the message browser. And the query service here is listening for both the messages coming from the photo service as well as likes service, and it is storing the information in its own database in order to be able to later answer the more complex queries, like, for example, what are the most popular photos in a given category. Now, on this architecture, we would like to demonstrate the flavors of modularity, which Eric was talking about. And the code modularity is here showed that we have 3 independent modules: the photo service, like service, and query service. And these modules are communicating via exchanging messages over the browser. Regarding the data modularity, each service has its own dedicated data store, and services don't access each other's data store or don't share data that way. Now, on the next slide, I would like to give you a more detailed view into how the persistence layer looks like. So the photo service is storing the information about the photo, which is the identifier of the photo, the name of the photo, and the category the photo is organized into. Like service has the simplest schema where for a given photo, which is identified by the photo ID, it's just keeping the count of the likes the photo obtained so far. And the query service is listening for the messages and building its own database in order to be able to show the most popular photos in the categories. Now I'm coming to the next flavor of the modularity, which I wanted to demonstrate, and that's the source code or source control modularity. As Eric already said, we are storing the source code for each of the services or modules into a separate Git repository. So our application is actually living in 5 Git repositories, and the first 3 here are holding the source code for each of the services. And besides that, we also have a photo gallery common repository, which stores the common definitions which are used by the services. And we also have a photo gallery monolith repository, which doesn't really contain any source code. However, it contains the POM file for Maven to be able to build the monolithic application by assembling together the 3 modules. Regarding the build modularity, our modules are jars which are stored in Maven and then pulled, and a monolith is built out of them. And before I will continue and we'll talk about the last modularity flavor, I would like to share my screen with you and show the source code in Eclipse. So I have my Eclipse here showing 5 projects. First one, the photo gallery common, is holding the common definitions for the modules. And we can see that there are 2 constants defined here, which is the names of the topics that we are publishing the photos messages and the likes messages. And we are having also a definition of the messages themselves. So this is the coupling between services defined in this project. And then I will show you one of the services, which is, we can look at the photo gallery photo service. And you can see that it is a Quarkus application. It's a REST service with 2 methods exposed. First method, create photo, is the method where the user sends a post request when he's creating a photo. And what we do here, we will take the information about the photo and we will persist it in the data store. And we also create a message that the photo has been created, and we publish that message onto the topic. Second method here available in this interface is read all photos, which allows the users to send a GET request and retrieve the full list of all photos which has so far been created in the application. So for that, we just call a list all and take all the photos and convert them into the response and send it back to the client. One more project I would like to show you is the photo gallery monolith. And in here, as I said, there is no source code. But what is important here is the POM file, which references the 3 modules and builds together a monolithic application. So after looking at the source code, let's switch back to the presentation and continue with the last flavor of modularity, which is the deployment modularity. And you can deploy our photo gallery application in 2 ways. Either you can deploy it as a monolithic application or as a set of microservices. If I talk about the monolithic deployment, then what you get is a monolithic process which consists of all 3 of the modules. And these modules communicate with each other over a Vertex event bus, which is an in-memory event bus. And next thing I wanted to tell is that because all 3 modules are stored or are included in a single process, you also obtain a single API where all 3 modules are available. And you can scale this application by replicating the entire monolith. Also, I'm using one physical database. However, the database defines 3 separate schemas so that each of those modules has its data stored in its own dedicated schema and they don't share. Coming to the second way of deployment of photo gallery, that would be the distributed or microservices deployment. You can see that each of the modules is running in its own service, and services are talking to each other again over a Vertex event bus. However, this time it is a event bus running in a clustered mode, so that the communication actually really traverses a physical network. So now we are looking at a real distributed application with all the downsides which are connected with it, like for example, the reliability of the network and other things. What is good though about this deployment is that you are able to scale each of the services independently. And what is even more important is that you are able to deploy new versions of the services independently. And one more thing I wanted to mention is that because the modules are each running in its own service, you would need for the client, which needs to talk to these services, the client needs to somehow discover the 3 endpoints which you are having there now. And you can either bring some facade service in or maybe use an API gateway to again expose these 3 services and 3 APIs as it will be a single API for the client.